Welcome to my YouTube channel Intro Math. Today I am going to discuss on the topic set theory. The topic will be split up in more than one classes as it is a very vast and interesting part of modern algebra. Keep watching, ask me any question if you feel any difficulty at any stage. To pass on to the main topic, we are first going to discuss some symbols which are very important to understand the set theory. So first we are discussing some symbols. These are not all the symbols we need to understand set theory, but these are sufficient for the preliminary concept of set. So this is the first symbol, and we will use it to represent belongs to. Belongs to means some element belongs to some team or some group. Okay, and this is simply equality sign, and after that if we cross the equality, and it will represent not equal to. So simply as that, this is belongs to, and this does not belong to. Okay, this will be used for all, and this will be used to represent and. This two dot will be used for such that. Also this will be used for such that. We know this symbol, and it implies that this symbol is for subset. This symbol is for proper subset, not this equality, not this line. Okay, without this line, this symbol is for proper subset, and this is both side implication. Okay, it will be used to represent if and only if condition. So these are the elementary symbols we will use in starting. After that, we will discuss the other symbols in the time of chapter discussion. For set theory, we now first have to know what is set. What is set? Okay, this is our first question. We have to know what is set. We cannot define a set. Is that understood? Okay, now see, I am writing 5 letters A, E, I, O, U. Do you know the similarity between these letters? Yes, we know they are all vowels of English alphabets. Okay, they are well defined, they are distinct. So these numbers can be put in a group, and they can be called a set. Okay, this is a set. A, E, I, O, U are called elements of the set A. So a set is we can say a set is, number one, well defined. Number two, collection. Number three, distinct objects. And number four, independent of order. well-defined collection of distinct objects which are independent of order. Independent of order means A, E, I, O, U form a set. If we write this E first, then A, then I, then U and O, this set is also a same set. Elements should not be in a same order. Order may be changed. So it is independent of order. These 4 points are to be clearly taken in mind, that a set is a well-defined collection of distinct objects which are independent of order. Must be well-defined. Must be well-defined. So this is a set. Okay, and these are called the elements of set. A, E, I, O, U are called the elements of set. Elements of set. And this is set. So set is generally represented by the capital letters A, B, C, D, etc. Set is usually represented by capital letter A, B, C, D, M, N, P, Q, etc. Okay, and the elements are represented as the small letters A, B, C, D, X, Y, Z, etc. These are the representation. Set is represented by the capital letters and the elements are represented by the small letters. Next, presentation of set. Set can be presented in 2 forms. One form is roster form, the other form is the set builder form. Roster means the elements are usually written within second bracket, and in this form is called roster form. Okay, represent, or we have already stated a set, the vowels, set of vowels A, E, I, O, U. This is the roster form when all elements are represented within second bracket. Actually, set is represented within, the elements are taken within second bracket. Okay, and now this set in set builder form, how it can be written? How it can be written in set builder form? Set builder form, it is represented as the set of all x such that x is a vowel of English alphabet. So we have already seen the notation. These 2 dots is such that set of all x, it is read as set of all x such that x is a vowel of English alphabets. So this is the rule. X follows this rule. X is a vowel of English alphabets. Which x? Who are vowels? That is A, E, I, O, U. So these are 2 presentation of set, one in roster form, the other in set builder form. I am giving another example of roster form and set builder form next. Look at the second example. B is the set of 2, 3, and there is a set in a set builder form. I am writing as set of all x such that x is the root of the equation x squared minus 5x plus 6. If we solve x squared minus 5x plus 6, then get 2 roots. One is 2, the other is 3. That is the set B. So these 2 are the same set. This also B and this also B. The presentation is the different, one in roster form, the other in set builder form. Another important aspect to be discussed here, if a set is written as 1, 2, 3, 4, 5, 6 up to 10, the natural numbers from 1 to 10, this is set A. We write 1 belongs to the set A. 1 belongs to the set A. But look at here, 11 does not belongs to the set A. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all belongs to A. But 11 does not belongs to A. Does not belong to A. Okay. So here we use belong to and does not belongs to. Okay. Now move on to some definitions in set theory. The first one is subset. Very interesting. Subset. Look, I am taking a set A, the even numbers of 1 digit, 2, 4, 6, 8. These are the even numbers. We are taking a set 2, 4, 6, 8 only in set A, and another set B we are taking 2 and 6. These are user defined. I am defining these two sets A and B. In A we have 2, 4, 6, 8. In B we have 2 and 6. Look at here, 2 and 6 also belongs to the set A. 2 and 6 also belong to the set A. So here B is a subset of A. We say B is a subset of A, and conversely A is a superset of B. A is a superset of B. B is a subset and A is a superset of B. So how we define subset? Here A here is the definition of subset. A and B are two sets. A subset of B if and only if for all x belongs to A, x belongs to B. For all x belongs to A, those x belongs to A must be belongs to B. It doesn't matter the which elements belongs to B is also in A. We don't need that for subset. When A is a subset of B, then all elements in A must be in B. That is A is a subset of B. Can you tell me what is this set? This A set is set of all x such that x is an integer and x lies in between 2 and 4. So we all can say that this set contains only one element 3, because 3 is the integer, lies in between 2 and 4. This type of sets are called Singleton set, in which there is only one element. So the Singleton set is the set in which there is only one element. That is called Singleton set. In continuation with the Singleton set, if we simply change some definition, here in Singleton set, set of all x such that x is an integer and x lies in between 2 and 3, which element belongs to the set A? Here simply there is no element in this set. There is no element in this set. So this set is written only like this, only 2 second bracket written here, the blank. This set is called null set or void set or empty set. Null set or void set or empty set, in which there is no element. It is called the null set and it is represented by phi. It is represented by phi. This is the null set or empty set. In any discussion of set, the largest set is called the universal set. The largest set is called the universal set, and generally it is represented by U, or wherever it can be represented by S. Okay, the universal set. If you want some specific example, let us consider the set, the number system, the real number system, in which there is integers, there is rational numbers, there are negative integers, there are irrational numbers, but the whole numbers, these all real numbers, are put in a group, the set of real numbers, the capital R. This is the set of real numbers, the set of real numbers. In case of the real numbers, this set, this R is universal set. So I think it is clear for you that universal set, in some extent, in some discussion, the largest set is always represented by universal set, or that is by U or by S. Next, equal sets. Equal sets. Two sets are given, A and B. How they will be equal? If A is a subset of B and B is a subset of A, then this will imply that A is equal to B. All elements of A are in B and all elements of B are in A, then A and B are equal. They are the equal sets A and B. Next, we discuss the proper subset. Which are the proper subset? Let us take a set A equals to set 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. We always know that the empty set 5 is subset of every set, because logically empty set does not contain any element. So empty set is subset to all other sets. And the set A itself is a subset of A. The set A itself is a subset of A. Besides those two sets, we have 1, 2. If we take 1, 2, a set, this is a subset of A. 3, 4, 5 is a subset of A. And any other combination, 1, Singleton Set 1, Singleton Set 2, or 1, 4, 5, any other combination of elements from A are the subsets of A. These two sets, besides these two sets, all other sets are called proper subset of A. All other sets are called proper subset of the set A. Move on to a very interesting definition, power set. Power set of a set A. We have taken a set A of elements 1, 2, 3. Simply you can see the three singleton sets 1, 2, 3. These are the subsets of A. If we take 1, 2 a set, this is also a subset of A. 1, 3 is a subset of A. 2, 3 also a subset of A. There are other two subsets of A which are phi and A itself. These all subsets are taken in a group and is called the power set of A. This is the notation. P is written as like this, power set of A. So power set of A contains the all subsets of the set A. Power set of A is a set which contains all subsets of the set A. This is called the power set. Complementary set. Complementary set. Here we are taking U, the universal set, as a set 1, 2, 3 up to 10. To understand this definition, we are simply taking U as 1, 2, 3 up to 10, a universal set in this context. If look at these two sets A and B, A contains 2, 4, 6, 8 and 10, B contains 1, 3, 5, 7 and 9, and C, I have taken another set which contains 1, 2, 3, 4 and 5. Here look, which elements belongs to A does not belongs to B, and which belongs to B, those elements do not belong to the set A. Here A complementary of the set A is represented by AC or by A bar, which is equal to U minus the set A. Leave those elements from U which are in A, that is the A complement. So which are the A complement? 2 here, so 1, 3, 5, 7 and 9. Simply it is the B, set B. Also the complement of B is the set A. Complement of the set B is the set A. Here the complement of C is not defined. The complement of the set A, C is not defined. We can easily say U complement, the complement of the set U or universal set is equals to 5, and the complement of the null set is U. Complement of the null set is equals to U. Hope you have enjoyed the video. Please like, share and subscribe the channel as much as possible. Have a good day.